A parallel plate capacitor of plate area and separation is filled with the dielectric constants K1 and K2 as shown in this figure. Find the net capacitance of the capacitor. You know very well the capacitor is represented by parallel plates. Now we have introduced a dielectric in between the capacitors. So these dielectric constants are K1 and K2. So given a parallel plate capacitor that is filled with the two dielectrics K1 and K2 stacked vertically. The distance between the plates is D and the plate area is A. So the dielectric each dielectric occupies the half space that is D1 and D2. D1 is equal to D2, that is equal to D by 2. Now let us go one by one. Here the dielectrics are stacked in series. So in that case, we are having the effective capacitance as series formula. So we know the capacitance, the effective capacitance in series, that is 1 by C1 plus 1 by C2 is equal to 1 by C. We know the formula of capacitance in terms of Ka and there is a permittivity also. So C1 for case 1, C1 is equal to K1 epsilon naught A. A is the plate area divided by D by 2, its distance. Then C2, K2 epsilon naught A divided by D by 2. Now the net capacitance is 1 by C1 plus 1 by C2. We can replace this equation and therefore D by 2K1 epsilon naught A plus D by 2K2 epsilon naught A. So here D epsilon naught to A being constant that can be taken outside the bracket. So the remaining is 1 by K1 plus 1 by K2. And therefore, now we want to have the net capacitance. So let us reciprocate this. And before reciprocating, you can do one thing. You can solve this, that is 1 by K1 plus 1 by K2. So take K1, K2 as the LCM. Therefore, K2 plus K1 divided by K1, K2. And that is also reciprocated. Now you are able to get C, that is net capacitance is equal to 2 epsilon naught A divided by D into this 1 by divided by 1 by K1 plus 1 by K2 that we have already done. So K1, K2 divided by K1 plus K2 into 2 epsilon naught A divided by D. So this is the way we have to find out the final capacitance or the net capacitance.